Flight in birds is a complex adaptation resulting from a combination of morphological and anatomical features. These adaptations allow for efficient and controlled flight. 1. Morphological adaptations. These are external physical features contributing to flight. Streamlined body shape. Birds possess a fusiform, spindle-shaped body that minimizes air resistance during flight, thus improving aerodynamic efficiency. Wings. Wings are crucial for generating lift and thrust. Their shape and size vary depending on the bird's flight style, e.g., soaring, hovering. Feathers. Feathers provide lift, control, and insulation. Their lightweight yet strong structure, along with their ability to interlock and create a streamlined surface, is essential for flight. 2. Anatomical adaptations. These are internal structural features supporting flight. Skeletal system. Birds have lightweight yet strong bones, many of which are hollow or fused for increased strength and reduced weight. This reduces the overall mass, making flight more energy efficient. Muscular system. Powerful flight muscles, particularly the pectoralis downstroke and supracoracoideus upstroke muscles, are responsible for wing movements. These muscles can comprise a significant portion of a bird's body mass. Respiratory system. Birds have a highly efficient respiratory system with air sacs that provide a continuous flow of oxygenated air, vital for the energy demands of flight. This system aids in sustaining prolonged flight. 3. Other adaptations. Metabolic rate. Birds have a high metabolic rate to generate the energy required for flight. Visual system. Excellent eyesight is crucial for navigation and prey detection during flight. In conclusion, bird flight is a remarkable evolutionary achievement, the result of a complex interplay of morphological and anatomical adaptations working together to enable powered flight. These adaptations have allowed birds to exploit a wide range of ecological niches and environments.